Hello and welcome to my channel. I am the Mad Computer Scientist. On this channel, I discuss math, technology, and computer science topics that are of interest to me. But before we begin with today's topic, I want you to do me a favor. Be sure to hit that like button. If you are new here and have not done so already, be sure to subscribe to the channel by hitting the subscribe button. Be sure to ring that notification bell as well so you will always get updates whenever this channel posts a new video. So today we're going to discuss why do ChatGPT, Gemini, and other large language models, also known as LLMs, get things wrong sometimes. I know you've all seen those posts on Twitter and elsewhere about, I believe it was the Google AI assistant suggesting using Elmer's glue on pizza. And of course, while we all laugh at these, I think we fundamentally misunderstand something about what LLMs are designed to do, so let's get into that. To start this video, I think we have to clear up a fundamental misunderstanding that many people seem to have about what programs like ChatGPT, Gemini, Grok, and other large language models are actually designed to do. Now, I would also recommend, if you haven't done so already, going back and watching my video on the Turing test, and I will try to post a card linking to that video on this slide. Now, LLMs are not designed to give you the right answer. What they are designed to do is to give you an answer that sounds as human as possible, and they do that fairly well. They use a complex process to do this, which uses statistics, linear matrix algebra, and a bunch of NP-complete problems, which is why it takes a while for LLMs to generate their responses. So just remember that the LLM is just trying to give you a human-sounding response, and because it's doing that, like any human who doesn't necessarily understand the topic either, because LLMs actually don't understand anything, they will sometimes spout out an incorrect answer. When a large language model gives an incorrect answer, that is called a hallucination. Because many people expect the large language models to give the correct answer all the time, they generally laugh when these LLMs get things wrong. What they don't understand is that there is a number of reasons why a large language model will spit out a wrong answer. Sometimes it's something as simple as inaccurate training data. These LLMs use a large portion of data from the internet, and the internet is not known for being highly accurate about many things. Another issue that can occur is that a human using a program like ChatGPT will ask something that the program can't actually compute, and the program will try to give its best sounding response, but it won't be able to come up with something that is actually related to what the human asked. This is just a natural consequence of how large language models are designed. Remember, as I said earlier, LLMs give human-sounding responses. They are not supposed to give you the right answer all the time, and I will probably keep harping on this point because it's important, and I think many people are missing this when they discuss the wrong answers on places like Twitter, Facebook, and other social media sites. The viewer of this video is probably wondering if there's any way we can eliminate hallucinations in ChatGPT and similar programs altogether, not without changing the way they fundamentally function. The way LLMs work requires hallucinations from time to time, even if all the training data used for the LLMs is accurate. In fact, in a preprint paper called Hallucination is Inevitable, an Innate Limitation of Large Language Models, Zhu, Zhane, and a name I am not going to try to pronounce, say, specifically, hallucination is defined as inconsistencies between computable LLMs and a computable truth ground function. By utilizing results in learning theory, we show that hallucination is inevitable for computable LLMs if the ground truth function is any computable function. Since the formal world is part of the real world, we further conclude that it is impossible to eliminate hallucination in the real-world LLMs. So keep in mind that this study is just a preprint. It's not been peer-reviewed yet, but I do agree with what they're saying here. We cannot get rid of LLMs' hallucination problems with the way LLMs are designed to work. Keep in mind that an LLM is just always calculating the next most likely word in a sentence. That's all it does. And when it operates that way, hallucinations, even if all of its training data, are inevitable. And if you're looking for a more simple breakdown of what they said, basically, if you have a function we can easily compute without using an LLM, it is going to come up with a correct result for that function all the time, while the LLM will not if you use both the computable function and the LLM to try to find the right answer. At this point, the viewer may ask, if ChatGPT and other large language models are so bad at getting things right, then why is every CEO pushing for them? Well, the answer there is simple. CEOs are pushing for them because it increases their bottom line and drives stock prices up. Remember, the CEOs of tech companies, and this includes Elon Musk, often have little understanding of the technologies they promote. Another guilty party in the push for LLMs is us. We want these things because they can do cool things. We can have the AIs create art that is probably plagiarized. We can also have these text-based LLMs generate poems, stories, and even computer code for us. But keep in mind that a major issue with the large language models is who controls the data. And all of this is fine, but people need to understand what the issues surrounding large language models and generative AI are, especially when it comes to copyrights, and more importantly, what the limitations of these are. By the way, people shouldn't feel bad if they don't really understand it either. Even very smart people, like the person I'm showing here, do say things that are just outright wrong.
It's all the same to
now,
them.
I'd like to point
That's
out
the
that Dr.
danger,
Michio
that they could
Kaku, shown
incorporate
here,
teenagers
actually
ranting
does
and
have a
raving about all
PhD in
sorts of
physics, and
garbage,
he's smarter than I
put
am.
that in
But
with
let's hear what he
articles
has
that
to
sound
say about all
reasonable.
of this, because I have some questions
That's the
for
problem.
you.
Now here's where quantum computers come in.
That's the danger, that they could incorporate teenagers ranting and raving about all sorts of garbage and put that in with articles that sound
remove all the
reasonable.
nonsense in these articles, and
That's the problem. Now here's where quantum computers
in other words, the
come in.
hardware may be
Quantum
a check
computers can act
on
as
some
a
of the
fact
wild
checker.
statements
You
made
can
by
ask a
software.
quantum computer
But
to
the problem with
remove
that
all
is
the
who's
garbage,
the
remove all
arbiter
the
of the
nonsense
information?
in
Like,
these
who
articles,
decides
and it'll do that.
what's real and what's
So,
not? How
in
does
other
the
words, the
chatbot
hardware
decide?
may be a
Is the
check
chatbot
on some of the
ideologically
wild
biased?
statements
The
made by
chatbot
software.
doesn't. The chatbot
But the
simply
problem
spits it
with
out.
that is
Yeah,
who's the arbiter of the information? Like, who decides what's real and what's not? How does the chatbot decide? Is the chatbot ideologically biased?
The chatbot doesn't. The chatbot simply
The quantum
spits it out.
computing does.
Yeah, quantum.
Excuse me, Dr. Kaku, I have a question about what you just said. It seems you do not understand that hardware and software are different things. Even if the hardware can help quantum computers fact-check large language models, it will still be done on a software basis. It may be done by firmware, which is a mix of hardware and software. Quantum computers do offer faster processing times than current digital technologies, and this is because quantum computers use qubits instead of binary bits, and their logic gates rely on quantum effects which operate faster than our digital computers do. Unfortunately, creating a quantum computer, if it ever does become commercially feasible, does not mean that quantum computers will not need to use algorithms. They will still need to be programmed. There are even specific computer programming languages for quantum computing. Even if we develop an algorithm that does what you are suggesting, it also won't do away with theoretical computer science. We'll still have to worry about runtime complexity on a quantum computer, even if an n-cubed algorithm will run much more quickly on a quantum computer than it would on a digital algorithm. Also, make sure, if you ever write an n-cubed algorithm, to try to find a way to do it more efficiently, because that is pretty slow. So, Dr. Kaku, what I want to know is, how are we going to develop the fact-checking algorithm you're proposing? I do not want the viewer of this video to walk away with the idea that I hate large language models. I don't. I think they're really cool. I think they're the closest we have gotten to producing something that can pass the Turing test. But remember that ChatGPT, Gemini, and similar large language models may be amazing productivity tools, but, and tech bro CEOs take note, they are not capable of replacing human workers in their current form. Many tech companies, I think, are heading for a situation where they're going to have to hire back a lot of their human workers because LLMs cannot pick up the slack. Worse than that is that the capabilities of the current technology used by these chatbots may have peaked, and we are currently in a cycle of diminishing returns from these models. As a user, what you need to do is exercise caution when you get anything that requires factual information from a large language model. Sometimes you will not get the right answer. A good example of this is when I asked what was then Google Bard to produce the caret-suba multiplication algorithm in C code. What it returned would multiply numbers correctly as long as the numbers were less than 100. If you put in any value to be multiplied that was greater than 100, it returned 0. How did I know this would happen? It's not because I ran it, it's because I saw what the program was doing, and at some point it forgot to stop dividing, and when it kept dividing, eventually it would reduce to 0 in the compiler. All right, everyone, remember to like, comment, and subscribe. Now go out and write some code.